everyone, welcome to GemChem. Now today's video is on alkenes part 4 video, and here we will learn about dehydrohalogenation of alkyl halides, that is preparation of alkenes using this method. Now before starting, if you have not watched the previous parts of alkenes, then please do watch it. I will give the link in the description box as well as the I button present above this video. So let us start today's video. Now dehydrohalogenation is basically a removal of hydrogen as well as halogen from the molecule to give an alkene, right? So for this thing, base is required. Most frequently hot alcoholic KOH is used. Ethanol is the common solvent for both alkyl halide and KOH, as KOH is more soluble in ethanol than that of NaOH, so KOH is preferred. Now synthetically, less important reaction, but alkyl halides are obtained from alcohols. So since we can see that we know that alcohols can easily be obtained and alcohols can generate alkenes, so there is no necessity to make alkyl halides and then obtain it by dehydrohalogenation to get alkene. So that is why it is synthetically less important. Now it follows E2 pathway, that is it follows bimolecular elimination pathway and one step and concerted process. The primary halides 1 degree lesser than second halide, that is secondary halides, that is 2 degree, and then tertiary halides. Elimination occurrence. Preference is for tertiary halides because, see now, for primary there is only one carbon attached, right? So on elimination, this positive charge is being successively stabilized by one eye effect. When secondary, they have 2 carbon atoms, right? So this has 2 inductive effects to be stabilizing it. And for the third case, there is 3 carbons attached for the tertiary one. So from each side plus eye effect, so as a result this will be more stabilized. So more easy elimination takes place from the tertiary ones. Now see the next one, that is the reactivity of iodine is most. Being bulky, it can easily get out of the molecule, being a good leaving group, whereas chlorine is least. Now 2 commonly used sterically hindered bases are potassium tertiary butoxide and lithium diisopropyl amine. Now we will see the examples. Now see this one. Here there is a molecule and we can see that here there is a halide. X can be chlorine, bromine as well as iodine. So their elimination takes place. On adding this base, this is our base, right? So this base abstracts this proton and it gives up electron and this gets out. So this is how the elimination takes place and we get this new bond, that is a double bond present here. Now see the next example. Here in this case, here chlorine is present here and hydrogen gets away from here. As a result, alkene is formed here. For this case also, here what happens, let us see. Here there is a proton, right? So this proton is being eliminated. So this bromine gives up and this comes here and this bond comes here. So this is the method of getting this product. Now we will see the mechanism. Now the basic mechanism involves E2 elimination, right? So how does it occur? Now see, if we consider this molecule, that is CH3, and this is our hydrogen, the first one which we have taken, and here a bromine atom, right? Now it follows an E2 pathway. So this base, which is ethanol, here attacks the hydrogen, abstracts it, leaves behind the electrons and this bromine comes out, Br minus. This is a good leaving group. Now the product is this one, that is CH3, here CH2, and the new bond which is formed is this one, right? Now this mechanism involves what? Number 1, deprotonation using the base, right? So deprotonation we have seen, that is this one, this step. Second is what? Departure of leaving group, that is this one. Departure of Lg, that is our leaving group, and the leaving group must be good. And the third process is rehybridization of reacting carbon centers from sp3 to sp2. What does it mean? Previously, this carbon and this carbon were both sp3 in hybridization, and now both these carbons are being converted into sp2 hybridization. So there is a third process which is rehybridization. So this is important. So we summarize the 3 changes which takes place in a single step of a biomolecular elimination, that is deprotonation by the base, departure of leaving group, and rehybridization of the reacting carbon centers. Now see this question. So what will be the answer in this case? We can see that there is 2 halide ions, that is iodine here and chlorine here. So what we think, that which one will come out? We know reactivity of iodine is greater than bromine and greater than chlorine, right? So from here only we can understand that this is going to come out. So what will be our product? What do we expect to be the product? That is, this one will be our product. Here it will remain as it is, and this iodine and a hydrogen present here will leave to give this product. So this is our product. Now we consider dehydrohalogenation of an alkyl halide can be regioselective. That is, there is a selection for cis or trans alkene formation. It is also stereoselective. The dehydrohalogenation is also stereospecific. These terms are being explained in the previous parts, so you can watch it, and details of these will be explained in separate video. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.